Hello, everyone, and welcome back to a new session for Computer Science 1. This session is about Chapter 10, which is characters, C strings, and more about the C string. So this particular chapter is basically going over a bunch of utility functions that the book is trying to show you. So there are utility functions provided by the C language, and it asks, not it asks, it helps you do operations on characters, on C strings, and on the C++ string. So we will go over those. Let me log in really quick to the whiteboard. Okay, so what are we up to? We are going over chapter 10. We are going to see character testing. We are going to see character case conversion. We are going to see functions for C strings. We are going to see strings, numeric conversion. We are going to see more about the C++ string. So by now you should know the difference between a C string and a C++ string. The C++ string is the string that you include using the include string. The C string is the C language string, which is an array of characters terminated by a null. So this is the plan for this session. So let's go ahead and starting with character testing. So with character testings, there are really a lot of utility functions. For example, one is the function is upper. Is upper. So is upper is a function that takes a character and it returns true if that character is a capital letter or false if that character is a small letter. There is a table on page 566. This table shows the functions for character testing, which are from the library C type. So C character type. And you have a few. You have is alpha. You have is alpha. You have is digit. You have is function. You have is space, and a few more. So the table tells you what each tells you all the functions, and it tells you what each function does. So is upper is for checking if a letter is an uppercase or a capital letter. Is alpha is a function that returns true if if the input is a letter from the alphabet. So zero if it's not a letter from the alphabet, some like symbol or pound or dollar sign. Um, is digit returns the true if the argument is a digit. So meaning from 0 to 9. Let me type it, for example, here. So 0 to 9. Is alpha meaning A to Z or A to Z? Is upper meaning A to Z? Is punctuation returns true if the argument is a printable character, uh, uh, even if it's space. Zero otherwise. So there are characters that are not printable, for example, null, um, and other few. So this is if printable. Is a space eventually if it's a space character. If the user enters a character and you want to check if it says if the user entered the space character. You have is lower, which is the opposite of is upper. You have that's it actually. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 functions in the table. Let me demonstrate, for example, is upper. Let's say, well, first I need to include CC type. This allows me to use those functions. So let's say I have a character called input. Then I ask the user to uh, enter any character, cn into L input. Then I can say, for example, if is alpha input, see out, you entered an alphabetical character. I can say if is digit, I can say if lower, I can say if upper. So is digit, you entered a numeric character. If is upper, you entered a upper or an uppercase. And is lower, you entered a lower case character, basically. So let me run it, F10. So next, F10, enter any character. Here I'm going to enter, for example, capital A. Enter. Is capital A an alpha numeric? Yes, it's alphabetical character. So next, is it a digit? No, it's not a digit, so we are not gonna see this screen on the screen. Is an uppercase? Yes, it's an uppercase. So next, is it a lowercase? No, it's not a lowercase. Next, so we're gonna see only 2 on the screen. Another example, for example, is 6. So enter. It's a numeric character. It's not an alphabetical character, and it's not neither upper nor lower because it's a digit. So that's a something for you to know. You can, of course, work with array of characters. So you can have a C string, which is an array of characters, and read that C string from the user, right? And then you can iterate that array and execute these functions on each character from that array. For example, let's wrap this. I want to surround. So surround with uh, for loop. And then I'm going to say int I less than let's say the size, let's say 8. And then I'm gonna say I need a character input of size 9. So meaning the size of the array is 9. Remember, it's terminated by a null. So if the size is 9, that means I can put 8 characters in that array. 9 is 8 for the characters and 1 for the null because it's null terminated. Then I'm gonna say enter 8 characters. Then I'm gonna say cin. I'm gonna use getLine into L input, and then I'm gonna say I need the size, which is 9, up to 9 characters. Well, up to 8 characters in that case. Then I'm gonna say is alpha for whatever character I'm on. And then same. So here I'm gonna say cout the character L input. And then by the end of this, I'm gonna print and L and L. This will show us a separation of info on the screen. So now if I run, I'm gonna say AE5 character M N. So how many? 1, 2, 3, 4, 5, 6, 7 and space. Enter. So for the A, you entered an alphabetical character and it's an uppercase. You entered an alphabetical character and it's a lowercase. You entered a numeric character. This one is not alphabetical and it's not a digit and it's not an uppercase and it's not a lowercase. This is similar to the A. This is similar to the E. This is similar to the character. It's not an uppercase. It's not an alphabetical character. It's not a digit. Space is the same. So, yeah, so this is for working on few characters. Then you have functions to convert cases, meaning I can grab a character from the user and convert it to the opposite case, meaning is upper or is lower will become the opposite. So two lower and two upper. So character case conversion. For example, I'm gonna take this out, and then I'm gonna say for this character, cout upper case is to upper L input at I, and then lower case is to lower and L. So this will return the uppercase of this letter, and this will return the lowercase of this letter, meaning whatever the character is, this line will display the upper case and this line will display the lower case, whether the character is already upper or is already lower. How would you use this? Well, let me show you first how it works. So for example, I'm going to say my name, capital letter, small letter, capital letter, small letter, capital letter, small letter, capital letter. So enter. Um, so it's an integer example of that character. Let me change that to be the character. So to upper this character, I'm gonna say character. I'm not sure why it wants me to do it this way. It should display a character. Um, hmm, interesting. So again, capital, small, capital, small, capital, small. So I told it I need 8 characters, but these are not 8. So the uppercase K, this is the uppercase, this is the lower, 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 same, same. And then those are empty, like junk, because I told it it's 8 characters. I told it to iterate 8 times. Um, so here what I did is this gave me the ASCII value of that character. So meaning if I execute again, and this time I'm gonna put all capital letter, this line returned uppercase is 75. 75 is the ASCII value of the capital K. So if I go to Google and I say ASCII values C++, and then I open it. It's in your book if you need it. It's like towards the end of the book. So here, if I go to the 75, 75, here it is, 75. So the 75 as an integer is the letter K. On the other hand, 107 is the small character. So 107, 107, here it is, 107. So when this returns 75, what I told it is, I told it I need you to construct a character, and I gave it within parentheses, and I gave it the 75 in this instance. Again, character, open parentheses, and the close parentheses, meaning I want to construct a character based on this value. And it displayed them for me. So this is helpful in, for example, let's say you want to compare strings and you don't care about their whether they are uppercase or lowercase. If they are the same, they are the same. For example, in email addresses, let's say I have character L database, for example, email equals k at ltu.edu, right? Let's say this is my email address. And you all know that whether I type this email in Gmail, if I compose a new email, if I want to write a new email and I type this email lowercase or uppercase, it's the same. So this email is the same as capital ltu.edu. Also, it's the same as capital, small, upper, lower, upper, lower, upper, lower, upper, lower at ltu.edu. So this email and this email and this email are the same. So Gmail doesn't care when it comes to emails, the email username. It doesn't care if it's an uppercase or a lowercase. That means if I have something in the database and then I tell the user to enter how many, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, the first part, 1, 2, 3, 4, 5, 6, 7. So if I tell the user to enter the email, and I want to make sure that, so my program needs to make sure that this is the right email, a match, right? Let's say it's a match, correct. Correct, this is the email. So I'm gonna ask the user to enter 7 characters, and then I'm gonna get those 7 characters. I'm gonna iterate those 7 characters. If I do right away, if I do something like this, L input at I equals or not equal L database at I, then out email is incorrect. And if it's incorrect, I'm gonna break. I don't need to keep comparing. As long as one is different, then the email is different. So with this setup, notice that it will break. It will tell me it's incorrect, even if I enter the correct email. So the one in the database is this. So now if I enter capital letter, let's put a breakpoint, enter, enter. So now notice they are the same. K, Kala, and K, Kala. Um, in, in the business logic, they are the same because emails don't care about capital letter, but the system, the program, is gonna think they are incorrect. So it's gonna say email is incorrect even though it's correct. So what I need to do in this case, before comparing, I need to change it to lower. So meaning I need to either compare both of them as lower or both of them as upper. So what I can do is I can say to lower whatever is the input is not equal to lower whatever is in the database. So by converting both of them to lower or by converting both of them to upper, now I can check. So let's go again and say kf at ltu.edu. Enter. So is the first character lower from the input is not the same as lower from the database? No. Next, next, next. It's gonna keep comparing up until it says they are correct. Oh, it did say email is incorrect. Strange. Why? Oh, we went out of so 7, 1, 2, 3, 4, 5, 6, 7. Let's do 8 from I don't need this. So why it did say incorrect? To lower, to lower. Go again. Get line. So I'm gonna say capital K Khalaf. Enter. So it's not. Let's change this. So it's not. Not. Where are we at? So we are at 5, which is this, and then the null. Oh, okay. That's why. At the null level. So I'm gonna say only 6 or read 8. So let's read 8, but compare only 7. I'm reading uh I'm reading 8. Well, it is 8 from 0 to 7, and then I'm gonna read 7, and I'm gonna compare only 7. So it should not go through 8. Let's do it again. Go, go, go. So 1, 2, 3, 4, 5, 6, 7. So I read 7, correct? Oh, so this read, this get line should get, see? It's replacing the last character with null. So I should tell this line to enter 8. So now it will read 1, 2, 3, 4, 5, 6, 7. Enter. So input now is K Khalaf with a null. So it didn't see it reached return and it did not say email is incorrect, meaning this is the same as small letter. So that's an example for when to use lower or to upper. So with that being said, we come to topic 10.3, C strings. So C strings is what you see in front of you. C strings in C++ is a sequential or a sequence of characters stored in a consecutive memory locations terminated by a null character. Meaning, what you see in front of you here, how many characters are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this literal is 15 characters. When I create a C string is an array of characters. When I create a C string, the C string will have the characters and it will have a null character at the end. So this L database, the size of it is 16 because it has 15 characters plus a null character. This size was assigned automatically. I didn't assign a character because I'm doing literal. In this example here, I'm telling it I want the size to be 8. Means I can only store 7 characters because 7 characters plus the null at the end. So it's literally storing in an array that looks like this. You're going to have the memory locations. And if I tell it the string is Khalil, double quotations. So all strings are double quotations and all characters are single quotation. So if I tell it the string is Khalil, it's gonna come and store these characters in their respective slot. So it's gonna say, okay, K is here, H is here, A is here, L is here, I is here, L is here, and then it will add the null character at the end. So this would become the size of my array. 1, 2, 3, 4, 5, 6, 7. It has 6 characters, but the size is 7. This null terminator is the sentinel. This will tell when the data, where is the end of the data. Meaning I can iterate based on not reaching the sentinel, not reaching the null. As long as I did not reach the null, I can keep moving forward. Once I reach the null, then I should stop moving forward. So this null character at the end indicates the end of the data. And that's the sole reason for it. The sole reason for a null character is to indicate the end of the data. Null character is the 0 value in ASCII code. So as integers, in integers, int, for example, my int. In integers, 0 is not meaningless. Like right now, if I ask you, for example, how many apples do you have? And you say nothing. What is nothing? Nothing is 0, right? If I ask you how many apples do you have and you reply with nothing, that means you have 0 apples. In C++ or in programming, 0 is not nothing. Not nothing. 0 is an actual value that indicates the value 0, the count 0. 0 is not nothing. However, now integers can't be null, or actually they can, but the capital letter. On the other hand, null character is nothing, emptiness. So if we go back to this, if I go ahead and I put the character 0, the character 0 might not indicate the end of the data. What if my array has a 0? What if my phone number, for example, is 208, right? 4456. This 0 is not the indication of the end of the data. 0 is not nothing. However, null is nothing. That means once the computer reaches an emptiness, a null character, an emptiness, a nothing character, then this indicates the end of the data. So 0 is not nothing, and null is nothing. Null means nothing, emptiness. So this is how arrays are stored in an array, which is the topic on page 574. C strings stored in arrays. And you already know from the chapter of arrays that this needs to be constant, and I can't allocate it on the fly. I can't allocate it on while the program is running unless I use dynamic memory allocation using pointers. So array of characters are constant pointers to variable data. I can have a pointer to a character and dynamically allocate a big bunch of arrays. And that case, um, it's dynamic. It's not static at compilation time. The topic 10.4, it's called library functions for working with C strings. So there are library functions that you can use to work with C strings. For example, strlen. So I'm gonna take this off. I'm gonna take this off, and then I'm gonna take this off. I'm gonna keep this. We have strlen, for example. We have strcat. Let's see what else. We have strcopy. Strcopy. We have strncat, strn copy, and then str, str compare, Mhm. Oh, the table is on page 585, table 10-3. strlen, strcat, copy, uncat, uncopy, compare, str. And there is a description for each of those functions. So len will return the length of a C string. So all these are functions for C string, only for C strings. So strlen will return the length without the null character. For example, cout strlen l database. How does this work? It works by iterating up until the null character. Once it reaches a null character, it terminates. So this should return 15. 15, because the characters are 15. Now database has 16 in it because 15 plus 1. strcat is to concatenate. So it accepts two strings, and the function will append the content of the second string to the first string. For example, let's say I have another one called domain equals at ltu.edu, and then l username is Khalaf. So now I can say semicolon. Now I can say str cat. I need l username, l database, domain, sorry. So this will display the entire thing. Error, the function array may be unsafe. Okay, use the underscore s, which is safe, or I can disable that warning. And template expression, da da da. So let's see what's wrong with this code. Oh, this doesn't return. What I need to do is I need to do like this, and then stop, and then display username like this. Oh, interesting. What's what? I might have to give it more. I might have to tell it, hey, you are 16. You only have this portion, but the rest will be a preparation for those. So let's try now. Enter. Where is it? Oh, here it is. I don't know why the buffer had something in it. So let's try again. Here it is. Okay. So I basically prepared space. I need to prepare space for whatever is gonna be concatenated. Otherwise, I don't have access beyond that limit. What else? You have str copy. So str copy is basically uh, taking one array as destination and another array as source and copying from source to destination. Meaning I can say copy from here, so from domain to username. So now username will become at ltu.edu. Here it is. I'm displaying username, so now username has at ltu.edu. So notice the book is telling you because these, so str cat and str copy, do not go beyond the array, so they might not be safe. It might crash like we just saw. So it's better to use str n cat and n copy because this takes a number. So basically you're gonna say str concatenate a number of characters. str str number str copy number of characters. So it takes a specific number of characters, which is eventually helpful. Oh, str will compare if one string is a substring of another string. So it's if one string is part of another string. And str compare will compare two strings if they are the same. So that's basically the table. Then we go to topic 10.5, which is a string slash numeric conversion functions. So these functions are to convert C strings or strings objects. So whether it's a C string or a string object from a character data to numeric data. For example, I'm going to take this off. I'm going to take this. I'm going to take this. For example, the number 2023. Let's say L year. So L year in this fashion is not the number 2023. It's the group of characters that consist of the character 2 followed by 0, followed by 2, followed by 3, and then null. Meaning I cannot say L, for example, int L next year equals L year plus 1. L year is not the numeric value 2023. It's an array of characters that has the characters 2023, not the value 2000s, 000s, 210s, and 3 singles. So I have functions that will help me do that. So for example, it is a or at OI. So at OI L year. So this at OI will take a C string and return the numeric value of this C string, return it as an integer. So now if I display next year, it will display 2024. Another one is at OL, which so this converts it to integer. And then you have at OL, which converts it to a long. And then you have at OF, which converts it to a float. So at OI, at OL, at OF. And that's table 10-4. On the other hand, so this is array to integer, array to long, array to float. On the other hand, you have a string to I, string to integer, string to long, string to F. String meaning the C string, which is the C++ string. Same fashion. This is not the numeric value 2023. It's the string 2023. So I can say string to integer current year, and this will now work. It will display 2024. On the other hand, I have functions that convert from integers to strings. So if I have, for example, the integer L current year int equals 2023, then I can convert this string, this integer to a string. So I can say I need a string L current year str equals 2 underscore string. So 2 string, and then I give it the integer L current integer year. So now this is the string 2023. It's no longer the value 2023. So here it is 2023 as a string. This toString is an overloaded function. So there is one for integers, one for long, one for unsigned long, one for long double, one for float, one for so basic for all data types. Whatever data type you give it, it will return the string representation of that value. Then topic 10.7 says more about the C++ string class, which is this one. The string class. This is the C++ string. Arrays or C strings are the C language strings. This is the C++ string. So it starts with telling you how to use the string. You basically need to include, you declare a string, and then you give it a value, double quotations. So those are the basics, and you should know already before starting, which is program 10-15 on page 599. Before you start with this topic on this chapter, you should know the program in 10-15. We already covered these basics about C++ thing. Then it goes to tell you how to read an entire line from the string, from the screen, which is using getLine. For example, right now, if I have this string and then I ask the user to enter the name, enter full name, for example, cn into L current, uh, so I have it as current year, but I'm gonna call it L full name. And then for the sake of demonstrating, I'm gonna see out it. So if I go ahead and say enter full name, okay, my full name is this, enter. Remember the CN terminates the read when it encounters space or a new line. So the CN started reading, and once it reached a new line, it terminated reading. It stopped reading. Then it saved Khalil in the string full name. Then I displayed it, so it displayed Khalil. What if I need to read, ignore spaces basically? What if I want to ignore spaces? I want to read entire line, whether it's a sentence or like this, two words, full name. Then I need to use the getLine function. So getLine as a standoff function, standoff utility. So getLine and takes source and destination, meaning from where do you want to read and then to where do you want to read. Now if I run it again, Khalil, Khalaf, even with the middle initial, it will read the entire line up until the new line character. Then they go about comparing and sorting string objects. They tell you that you can use the equal operator with string, so meaning like this. Eventually, we already know we can use the uh, equal assignment. And then they tell you you can use relational operators, meaning if you have two strings, you can use relational operators, meaning I can use if this is less than L full name to do something. In what cases full name is less than full name 2? In that case, it's less than not just by the size. No, it is one character at a time. So K, they get compared. If one is less than the other, then the string is less than the other string. So notice A is less than B. So this will say yes, full name, let's say first name. First name is less than, right? And then else, last name is less than. Do you agree? I assume you agree. So if this is true, then first name is less than, which is the case, and else it is last name. And now I'm gonna say L first name, and then L second name. And here I'm gonna say, and here I'm gonna say last name, not second name. L last name. So first name, last name. So it's interesting that I have very symmetric first name and last name. So which one do you think is less than? It seems like they are equal, right? Because they both have 6 characters. Are they equal? Well, no, they are not equal. K is not less than K. H is not less than H. A is not less than A. L. Now I. Is I less than A? As an ASCII code, I is not less than A. In that case, A is less than I. So I'm gonna see that last name is less than first name. Let's execute. Last name is less than first name. because the A is less than the I. If I swap, now I'm gonna see that first name is less than. Here it is, first name. So comparing two C++ strings. Then in table 10-7, they tell you the different ways of constructing string object. So I can construct a string object like this and read from the user. Or I can construct it using the parentheses, the constructor. And later you're going to learn about it in classes, the chapter 13, classes, more about or intro to classes. So this is another way, right? One way is without initialization. Another way is using the constructor of the class. Another way is using a different string. So string else some string that has a value. And then I can say string L first name, use the constructor, but some other string instead of literal meaning. So instead of literal, I can pass some other string. And also I can tell it specific number of characters. So let's see how many I have. I have like a lot of versions. See count. Here it is, count. I can tell it how many characters. I can construct it also using this way. So L first name, L first name. I can say I need the string. I can say I need the a character 10 times. This is another way of constructing. What else? I can construct it using a substring of another string. So you see this version, meaning grab entire. Or I can tell it I need to grab from index 0 to index, for example, 10, meaning grab 11 characters from some string and put it in first name. There are really different ways. These are the common ones. Then table 10-8 tells you the string class operators, which is what we noticed, but we're gonna go over it again. So you can do different things with the string class. So L last name. First operator you can use is what you witnessed, this and this. So the extraction operator and then the insertion operator. You can eventually use these with strings. I can cin right into L first name, and I can see out from L first name. Then you can also use the equal operator. You can use the plus equal operator. You can use the plus operator. You can use the bracket operator. And eventually what we saw, relational operators. So equals, we can assign, we can use L first name equals I can use the plus equal operator. So I can say L first name plus equal space Khalaf. So now it becomes Khalil space Khalaf. I can use the plus operator. So L first name equals, I can say L first name plus space. So now it becomes Khalil space Khalaf space. I can use this operator, so I can grab a character, L first character equals L first name at index 0. And this will return the character at this index. first name. And relational operators, we just noticed, we just tested them. I need you to go over table 10-9 and get yourself familiar with the different functions provided to you by the language. You have a lot of functions provided to you by the language, and they are very helpful, very useful. So instead of reinventing the wheel and building your own function, you can use those functions. So there is append. Sorry, 1 second. Okay, back. So there is append, assign, at, back, begin, C underscore str. So that's basically converting a C++ string to a C string. C underscore str. Capacity, clear, compare, copy, empty, erase. I'm not gonna read them for you. I need you to read them and get yourself familiar with them. And with that, we come to the end of our chapter. So this is it for the chapter. Uh, you should see the assignments inside the modulo. You should see, I believe I did a discussion topic, a homework, and a project. So please go ahead and start working on those as soon as possible. And let me know if you need any help or you have any questions.